This is Yihao from Jiangnan University. The title of our paper is FogMesh, 3D Human Mesh Recovery in Videos with Focal Transformer and GRU. High-precision 3D human body recovery in the wild is a challenging task. In addition to the common difficulties, such as inadequate inference from 2D to 3D, lack of sufficient 3D annotated data, occlusion, self-occlusion, etc. The challenges are also posed by high-speed motion blur and obscure characteristics of small-scale body parts, such as the hands. Here, we proposed a novel method taking the advantage of the focal attention mechanism to model both local and global interactions for 3D human mesh recovery. Our framework takes a temporal sequence as input to obtain grid features and global feature vectors using a CNN. The global vectors are fed into the GRU encoder to obtain keyframe hidden vectors. The keyframe grid features and the keyframe global vectors are tokenized and fed into the MFE, represents multi-layer focal encoder for 3D human mesh. In addition, we propose the CAA module, represents the contextual augmentation and spatial attention module, that integrates multi-scale features and highlights important elements via spatial attention. As shown on the left, the feature map F5 is processed by the spatial attention module and the dilated convolution with different rates. Multi-scale feature maps are fused through downsampling and concatenating. The CAA module effectively fuses the context post information and automatically adjusts the attention weights of small-scale body parts for a robust and discriminative feature extraction. And as shown in the right figure, the multi-layer focal encoder consists of 3 encoder blocks with the same number of tokens, including 49 grid feature tokens, 14 joint queries, and 431 vertex queries. When the input tokens are given and the contextual features are generated by the multi-head self-attention, we can improve the local interactions with the help of window attention. In brief, firstly, the input features are divided into different levels corresponding to the different granularity of attention. Secondly, different size of windows are set for different levels, and the self-attention operation is performed at the window level. Finally, the extracted fine-grained and coarse-grained tokens are concatenated to obtain local and global information. We conduct our experiments mainly on 3D PW and processed 3D PW datasets in our paper. The processed 3D PW is the 3D PW processed by us to simulate high-speed motion. The results show that our method outperforms previous methods on 3D PW and can maintain better generalization and stability in the high-speed motion scenes. Additionally, here are some visual predictions. The left figure shows the prediction results on the clear original images, while the right figure shows the comparison of the prediction results on the high-speed motion blurred images. Thank you for watching this video. If you got any questions, please send an email to us.